In this video, I just want to solve one more linear programming program using solver. So for this case, I want to apply this solver techniques for minimization problem. So the problem, the question is already given in your note. So if you go to your topic 2 note, you will find the Cohen Chemicals program. So in this company, Cohen Chemicals, they are missing two chemicals. One is black and white, and the other one is color. So I already set up kind of a template here. So X and Y. X, I want to use this for black and white, and the Y that indicates color chemical. So we are mixing this, and in this case, instead of maximizing profit, we are minimizing the cost. So let's fill in some cell values and let's formulate the problems. So X and Y, we do not know the solution, but we can just arbitrarily give some numbers. Let's say if it's 2 and 3, these numbers will change. But based on these variables, let's apply some formula to get the cost and the cell reference. So to do this, first, the cost function, if you read the questions, the parameter for X, that is for each unit, how much does it cost? 2,500. How about Y? It's 3,000. So given these parameters, how can we calculate the cost? So here we use the formula. So let's start with X, this parameter, and multiplied by the decision variable. But for this decision variable, since we are going to copy this formula for constraints as well, and those decision variables position, they are not changing. So we want to make a fixed position variable. So how to do this? Using function and F4. So we can put just the $sign in front of B and 2. So then when you copy, other cells will move automatically, but those cell with the $sign, the position will be fixed. So you know that this is just the basics of Excel. And then let's add what's the cost for Y? This Y parameter multiplied by this decision variable. And again, I want to fix the position. So function 4, and then I add parentheses. So this formula will calculate the cost for given decision variables. So currently, if you use 2 and 3, the cost is 14,000. So you can just play with those variables. So you can change it, and then cost will automatically change because we use the formula with the referencing cells, right? Now let's talk about constraints. Black and white constraint. Actually, X must be greater than 30. So in that case, the X parameter is 1, but Y parameter is 0. So just it's 1 and 0. That means 1X and there is no Y. Then this value must be represented as similar to cost. We can just copy this formula. So let me just copy and paste here. Then if you look at this cell, you can see that automatically the parameters are moved down here, but it is referencing this decision variables. So you now better understand what this $sign means. The positions for those decision variables are fixed, but now those parameter values moved down automatically from the second row to sixth row. So we can just copy this cost function for cell reference because it's the same format. Parameter, decision variable X plus Y parameter, decision variable Y. So same format is used for cost function and here in cell reference. Okay. So similarly, we can set some parameters for Y. In this case, it is kind of special. So there is no X but Y. Then we can just simply copy this formula again. So let me just drag down, and then you can see it is 3 again because Y value is 3. So if it's 5, you can see it's changing. So current cell reference is just X. In this case, it's just Y. But for total constraint, x plus y must be greater than 60. So 1 and 1. So the formula is x plus y if I just copy it, as you can see here. So 3 plus 5 is 8, so we can just confirm those cell references are working good. And this cell reference must be greater than or equal to 30. And this must be greater than or equal to 20. And this must be greater than or equal to 60. That's it. So, okay, now we are ready to run the server. So let me click the server. And here, set up the objective. What's the objective? So let's click. And this cost function. So it's a G2 cell. We want to minimize this. So let's click this. And the not maximization, we are minimizing. So click minimization. And the changing variables, so decision variables, we have two variables. So let's choose these two variables and click. So we set up these two variables. And what is the constraints? Let's add it. Set reference, this one, first one, and not less than, but greater than or equal to. What's the constraints? This 30 is constraints. So we are good. And I will just add, continuously add it. So second one, reference, this is reference, and it must be greater than or equal to this cell, HA cell. So we add this, and the cell reference, this one, total constraint, must be greater than or equal to. Actually, this one is just a 60. So we can just click OK. So now we have those three constraints. So we have three constraints, and we want to minimize this G2 cell by changing those decision variables, that's B2 and B3. And then there are several methods, but as I mentioned, it's a linear problem, so we can use a method called the simplex LP. You can use others, but let's just use the simplest one. So simplex LP method we are going to apply, and let's solve it. So if you solve it, actually you can easily get the solution 40 and 20 for x and y, and in that case minimum cost is 160,000. And if you want to get the answer report, you can just highlight the answer report and click OK. And then here you can find the new tab, answer report, and it will summarize the result. So we started from 3 and 5, but the final solution, actually this one is, let me see, 40 and 20. And when it's 40 and 20, original cost was 2,500, but now 160,000. That is the minimum cost we can get. So that's the solution. It's not that difficult, right? So if you could not get the correct answer, watch this video and repeat one more time, because for your assignment, you have to use the solver again. So you'd better understand thoroughly how to use a solver and how it works for linear programming problem. Thank you for watching.